Thank you guys so much for being here on this beautiful Monday, May day. And we are going to talk about geometry, one of my favorite things. When I taught second grade, I couldn't wait to get into geometric thinking. Okay, this is me, and if you happen to be watching this later on as a recording or on Facebook, and you want to get involved in the conversation or you have a question for me, please feel free to reach out and send me an email. And this is our website for the Kentucky Center for Mathematics. If you ever miss a session, or if you're like me and you want to go back and hear some sessions over again, this is where you go, and you can have all of our handouts as well too. Okay, so let's get into it. Today's agenda, let's do some math, and then we're going to talk about the standards and look into a little bit of research, the Van Hiele model, and principles and standards for school mathematics. And then finally, manipulatives, which are essential in all mathematics, but especially in geometry. So the very first thing to do, let's do some math. I have a slide up here, and this comes from the Math Learning Center, and it's entitled, "Which One Doesn't Belong?" So if you will please take a look at that picture and just think and describe in your own words. And the beauty of which one doesn't belong is that there is no wrong answer. Just look at the attributes of all of those shapes and think about which one doesn't belong. And I would love for you to put in the chat which one you think doesn't belong and why, or even better yet, unmute and tell me which one you think doesn't belong.
Got in the chat box because it's 2D or it's only 2D. Some I see 3 shapes instead of 2. Be brave and unmute, folks.
I must say, to go out on the limb, I would say B, because the objects are set on top of each other, where all the other ones, while there's multiple objects, they're separated.
Exactly, they can stack, can't they? And our kids might even say, oh, that one's got something blue in it, and none of the other ones have something blue. They might even go that route that's not exactly mathematical. So a lot of A's because they're not 3D. And we had a B because they stack. Can somebody think about why C might not be in those? Okay, just to be different. C is the only box with 3 objects. Fantastic, thank you. D, the cones have a point. Exactly, and your kids can have this rich math discussion just based on these 4 different sets of objects, sets of shapes, and talk about all the attributes and look at all the shapes, and there's no wrong answer, so there's an entry point for everyone, and they feel safe doing that. And I have a link if you get into my presentation later, and this is a link to this page, and it has all different grade levels of which one doesn't belong, and several different options for patterns and things that you can put on your board and just have a kind of a math talk or just a great level of discourse with your students about shapes. Thank you. Okay, so the standards. When we start in kindergarten, we are really looking at naming and describing the shapes and the things in our world and where they are, and knowing that no matter how we move those shapes around, they're still the same shape, and describing how they're similar and different, and making them and taking them apart. And then we move on to first grade, where they're talking about the actual mathematical attributes of the shapes and building and drawing those shapes, composing 2-dimensional shapes and 3-dimensional shapes using a composite of smaller shapes. And then we're going to start to partition circles and rectangles into halves, fours, and quarters. And then moving on to second grade, you're going to continue and build on that and even talk about more attributes of even more shapes And then you're going to start to partition a rectangle into rows and columns, which is a precursor for learning about multiplication and arrays. And then we're going to partition circles and rectangles into 2, 3, or 4 equal shares. So we're adding those thirds in. So we're building the foundation for fractions. So geometry builds that foundation for so many different higher level thinking parts of mathematics. Okay, so we're going to talk a little bit about the Van Hiele model, levels of geometric thinking, and it's just a 5-level progression of understanding spatial ideas, and each level describes the thinking process used in a geometric context. It's about describing what kind of geometric ideas we have, how we think about those ideas, and what the students are going to produce based on those ideas. So the 5 levels are visualization, analysis, informal deduction, deduction, and rigor. And we are going to focus on these 2 right here because we are going to live in kindergarten through 2nd grade today. So we are basically both focusing on visualization and analysis. And just like most of the progressions we talk about, the levels are sequential. Students go through all of those levels, but they're not age dependent. You might have a high school student still in level 0 or 1. It just depends upon the geometric experiences they have, and we have to make sure that our instruction meets the students where they are so that they can build on their thinking. Okay, so level 0 visualization is just what you would think it is. It's what they see. Figures are judged by appearance. They're looking at that figure that they have in their hand right in front of them. What the shape looks like, they need shapes that they can observe, that they can touch and feel and take apart and put together and work with in some way. And they're going to start to group shapes that seem to be alike. A circle is a circle because it looks like a loop. I grouped these together because they're all pointy. They look like a house. A square is a square because it looks like a square, and that's what my son told me. Why is that a square, son? Because it's a square. Couldn't tell me anything other than that. And the thinkers at this level, a rotated square is not a square to kids at this level because it's turned. So when I showed that shape to my son, I know you can think about what word he told me that was. He did not say it's a turned square, Mom. He said it's a diamond. And because his teacher has blessed it, I cannot unbless it out of his little mind. It's going to take some time. So we have to be really careful about the precise language that we use with students. So we need to give them multiple opportunities to engage with shapes and begin to see those similarities and differences between the shape, and that is when they will start to progress to level 1. And level 1 is analysis, and that's the descriptive level. They move past just seeing individual shapes. They can see shapes that belong to a group, and they can see the properties of those shapes. A square is a square now because it's a rectangle with 4 congruent sides. I know that what a rectangle looks like, so I can group all the rectangles together. But they may not see the relationships among properties. I used to love to think about these things when I was teaching geometry, how a square is a parallelogram and a rectangle is a parallelogram, but not all parallelograms, maybe the other. But they don't see those kinds of relationships between the shapes. So how do we get them to progress through the levels? And this is a great video from Doug Clements, and he is going to describe to us, and he's so funny. If he does great work, and if you Google him, you can see all kinds of different videos about early instruction, especially in the area of geometry. So we're going to watch a quick video about the implications for instruction in geometry.
lesson. Geometry and measurement. From preschool to high school, traditional instruction in the United States is a wasteland here. The University of Wisconsin researchers found that first graders are more likely to count the sides and the angles of polygons to differentiate one from the other than third graders were. We actually teach it out of them, okay? And it appears on all these kind of tests. So what do kids know, and why do they suffer like that? Well, they know a lot. We gave this test to kids. You might think, why did you give them such a test with like paper and pencil tests with numerals all over it to really young kids? And the reason is, Mike Batista and I had given this same instrument to 1,500 kids from 6 to 12 years of age. And we wanted to see how kids 4, 5, and 6 would compare, okay? And they did pretty well. They did 92, 96, and 99% for 4s, 5s, and 6s on that. They did 82, 86, and 91% on squares, even with some real distractors in there, right? Triangles are a little lower, about 60%, and rectangles a little lower again, but still about 50% correct on rectangles. So what did we do? We found that kids knew quite a bit when they entered school just about simple shapes like this. This is Mike Batista in my research out here. Can you imagine if you were a principal of a school and you had to show this graph to parents and said, look at what we taught your kids this year? That's like the flattest graph you could find. And this is just low-level naming of shapes. It's a little better for triangles, but not much better. How come? Because this is what kids see in school. My son brought this home. Okay. Hey, one good thing about it, the triangle doesn't have a horizontal base up at the top. Okay, so that's different, right? But you know how the publisher puts a dotted line around it so that not only can you read the instructions down here, but they provide you a model? Look at what they chose as their best example of a triangle. It's got a hook, right? Mathematics, number and shape are important constituents of mathematics, but at its fundamental base, mathematics is about precision of reasoning and thinking. Precision of reasoning and thinking. This is slop, okay? Let's take a look at some others. Sailboat. He got credit for the sailboat, and he might have been looking at those two triangular sails, but he circled a pentagon, right? And he got full credit. And what's the sandwich doing here? All right? Nah, we don't need that kind of stuff. But my favorite is this one, okay? My favorite's this one because I remember it well. It's burned into my memory. I was presenting, and if you think, okay, he's not a very good presenter now, but I was worse before, okay? This was my first time out, and I was presenting my dissertation, and I turned my back to the audience, and I have like 500 numbers on the screen saying, Lincoln, you can see from my research, you know, and stuff like that. And next door was a guy who was also talking about early childhood math, but he was doing math and music. And there was a partition, you know, folding partition between the two rooms that wouldn't close. I know, because I grabbed that thing and tried to close it. It would not close, because his speakers were right on the other side of the opening, so the music's wafting in, and everybody's laughing and singing next door, and I'm there, and now you can see from my research. And every time I turned around, 5 more people were gone from the back. They went next door with the other guy. So you know when a presentation's gone wrong, you start sweating and everything, you know, you're all nervous and everything. And then at the end, Jackie turns over to the person next to her and says, why do we have to sit in the front? We can't even leave now. You know, it was miserable. Miserable. Finally, it's over. I go next door and say, be big about it. Go next door and find out what they're doing. So you should do more of that stuff. You know, you're just not motivating. Nobody wanted to hear what you had to say. So I went next door and I got the song sheets. Now, I don't know the tune to these because I was trying to present. I was sweating at the time. And but take a look. Take a look at the kind of math and music they were doing. Let's look at the last verse here. What's a triangle with sides of 3? A piece of pie for you and me. No, it isn't. Oh, maybe they get better. Wait a minute. What's a triangle with sides of 3? A piece of pie for you and me. A musical triangle. Ding, ding, ding. Let's call the triangle. What's wrong with a musical triangle? It's a mathematical model of a triangle. It doesn't even meet, right? And what else? It's not, it actually doesn't have a corner, a vertex, right? The vertex is two straight lines that come to a point, but they're all curved. I know we call it a triangle, but it's not a good example. Well, I'm sure they get the last one. What's a triangle with sides of 3? A piece of pie for you and me. A musical triangle, ding, ding, ding. A slice of pizza with everything. Oh my God, that's a section of a circle. They got 3 out of 3 wrong. This kind of stuff breaks the Hippocratic Oath. Kids would be better off if they didn't come to school the day they did this kind of song. That's no way to integrate math and music. Get rid of that too, all right? We got to move beyond naming basic shapes to getting kids thinking with precision about shapes and their property, making mental images, transforming shapes, playing with shapes, investigating shapes.
Okay. So, any comments or thoughts about what we just saw? And you can put it in the chat or you can unmute. About that type of instruction that he's talking about and how we need to move from that imprecise language. Julie says attributes, attributes, attributes. Absolutely. Have you seen a worksheet like that? I have. It's come to my house before. So I know that those worksheets are still in existence, are still coming home, and those kind of songs. So does it really matter if we're using precise language or imprecise language? So let's talk a little bit more about that. Okay, so the principles and standards for school mathematics said that we should be looking at, and this is K through 12, properties and shapes, locations, transformations, and visualizations for geometry. And in the K through 2 world, when we're thinking about the properties of shapes, we want our kids building and drawing shapes, comparing shapes by their attributes, putting together, taking apart shapes, identifying shapes in the real world, and examples and non-examples of shapes. So I have some triangles down there, because no matter how we turn or flip a triangle, it's still a triangle. If it's equilateral or isosceles or obtuse, whatever kind of triangle it is, getting kids to see that those attributes, that's what meets the rule of a triangle. Okay, so kids, especially in K1, 2, are all about what's going on around them in the world around them. So just thinking about the shapes that are in their world. And these are pictures right here from my hometown. We have that bridge right across the Ohio River, and it's just a beautiful piece of geometric work. And you could talk about the geometry of that bridge forever. And we have that mural underneath that bridge with all the different shapes on there. And it's a great way to talk to students about shapes. And then the one in the upper right-hand corner is just for my house. The furniture there has all different kinds of shapes. So there are shapes in the world around kids. And you can just have them talk about that. In the Vanderwall book, it talks about going on a shape hunt, but being specific about what you're looking for, because sometimes kids get overwhelmed if we don't make an exact target. So say, okay, today we're going to look for squares or triangles, and have them look for those things in their world. And then sorting and classifying. Kids need to sort, 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 all kinds of things. Up in the left-hand corner, Asher sorted those things for us. I said, just pick some of these things out and put them together. And he chose a balloon, an orange, and a soccer ball from the stuff I had laid out. And he said they're all balls. And that was the only reference he had for putting them into that group. Then I did the other ones next to it. I have some cylinders, and then at the bottom, I have things that stack, things that roll, and then in the middle of those, things that stack and roll. And those are just hula hoops that you can use to do large group sorts. Okay, another part of what students in geometry need experience with is location. And in K through 2, we're talking about their life and things that are happening to them. And we're talking about above and below, beside, behind, in front of, next to, and describing landmarks in the space around them, and then getting into the concepts of distance and direction. So you can see that little sweetheart down there at the bottom, making a map of things that are important to him in his world. And then transformations. Kids naturally use transformations in K through 2, such as slides, flips, and turns, intuitively, because when they're doing puzzles like the tangram puzzle down below, they have to manipulate the pieces to be able to make them fit and make the pictures that they want to. So they're using those things intuitively. They know that things can slide. They know that shapes can flip and what that would look like. Because we want them to be able to visualize, and when I hear visualize, it's thinking about the mind's eye, what you see in your mind. So it's creating a mental image of a shape. So if I asked you to mentally think of a triangle, you would be able to do that because you have a reference for what that looks like. And then if I asked you to mentally turn it a quarter turn, you would know what that would look like in your mind and how that would change the triangle. Then if you could imagine to partition that triangle into 2 pieces and what the 2 pieces would look like, you'd have 2 new triangles. And then a very interesting one is to predict how a shape would look from a different viewpoint. And in the Van de Waal book, it gives this great activity where you can have students think about, okay, you are standing next to a cube. Now think about what that looks like. Now think about if you were inside of the cube or the cylinder. What do you see on the top? What do you see on the sides? Just being able to visualize what those shapes look like. So to be able to develop those skills that kids need in geometry, they need manipulatives, and they need to touch it, feel it, move it, and be able to manipulate and work with the shapes. And one of the manipulatives that I like to use are tangrams. And you can see the tangram starts out as a large square, and it has these shapes inside of it that break apart and break off. And you can make different pictures with the shape. And I loved using Grandfather Tang's story. And as you read through the story, this grandfather is telling his little granddaughter a story, and he's using the puzzle to make the animals in the story. So it's a great way for kids to see how to use the tangrams and to have that practice with those. And then NCTM has a great website where if you don't have tangram pieces, they will give you the puzzle and you have the tangram pieces here, and you can change their colors. And in order to make the pictures, students have to slide, they have to flip, they have to be able to rotate the pieces. So all those things we want them to be able to do, and they have to be able to visualize what the picture would look like, and they have to know their shapes. So it's hitting all those different aspects that we want kids to learn. Toy Theater also has a great website where you can see a picture, and then the student has to visualize, okay, if I'm going to make this rocket ship, that's a triangle, and then there's this triangle, but he needs to be turned, and just manipulating the shape using all the same things that we just talked about. So tangrams are a great manipulative to use with our little ones when we're learning about shapes. Another manipulative that I like to use are pattern blocks. Pattern blocks are essential for any K-1-2 classroom, especially when you're learning about geometry, and they're pretty universal. They come with these shapes. Investigations has some great games. So when you go to Investigations, you can pick your grade level and go to the games about geometry. I especially liked this one. It's for 2 players, and player 1, the objective is to fill the hexagon. So you take a turn and you get to spin the dice. Oh, I got 2 hexagons. So I'm already pretty far along. So then it would be my partner's turn, and you press partner number 2. and they get to spin. And this time he got a rhombus, and I have to slide the rhombus in, and I'm going to slide the triangle in, and I'm going to think about what shape do I hope I get next, and what am I going to have to do to that shape? I'm going to have to turn it for it to be able to fit in that hexagon. And there are several websites here for pattern blocks because they all do different things. So in that one you were playing a game, and there are many games on there for geometry and different levels. And then the Math Learning Center, you can, just like in the tangrams, you can get a picture. Oh, there we go. And I liked this one especially. Okay, there we go. Because you can see how it transitions from the triangle and different shapes that you can do. And this is part of your standard to be able to compose larger shapes out of smaller shapes. And you would be able to see, oh, I need a triangle there. So it takes 2 triangles and a rhombus to fill this particular triangle. And this rhombus is made up of 2 triangles. So you can see those different kinds of things when you're working with pattern blocks. And then NCTM has a shape tool, and I wanted to show you this one because it has a really nice feature. Let's take this hexagon here, and we're going to enlarge it a little bit, because one of the standards was to partition it into halves, fours, and thirds when you get to 2nd grade. So you can cut this little shape in half, and then you can pull it apart to see what 2 shapes make up this bigger shape. Well, what if I'm going to cut it into fourths this time? Oops. Ooh, that wasn't very good. Try again. And then you'll be able to pull those pieces apart. I didn't cut it very well, sorry about that. All right. And then the patch tool, which is also on NCTM Illuminations, is very similar to the other ones. It gives you a picture, and you manipulate the shapes to be able to put them where you think they need to go to make the shape, using visualization and all those other things that we need to learn in geometry that we have been speaking about. Another manipulative I like to use are Geo Boards. And when I was in 2nd grade and I taught with Geo Boards, one of the things I like to do was read The Greedy Triangle by Marilyn Burns. And if you haven't read this book, it's just a fun book about this triangle who is never happy and always wants one more side and one more angle. So you could have your kids start off with any triangle. I didn't tell them what kind of triangle to make. They just started with a triangle. And as it goes through the book, she's adding one more side and one more angle. So then we go from the triangle to the quadrilateral, and we all look at the shapes we made, and not everybody makes the same quadrilateral. And we talk about those kind of things as we go through and look at our Geo Boards. The Math Learning Center has a great Geo Board, and you just pull the rubber bands just like you would on a real Geo Board, and you can make all different kinds of shapes. So there's my square, and if I wanted to think about, well, what shapes make up a square? Well, there I can see that it's 2 triangles that can make up a square, and I can look at different shapes within that Geo Board. Okay. All right, Glowstick Geometry. I know Julie has done some bedtime math work. I used to do an after-school club when I was a teacher, And Bedtime Math has all kinds of free resources if you ever want to do an after-school club, and they will send you the manipulatives that you need. But you can see there the kids are building with glow sticks, and they did have a promotion where they were even going to send the glow sticks to your kids, but they ran out of them. But I got these at the Dollar Tree just for $1, a whole bag of them, and they loved it. They would have sat there and made shapes all day long with these glow sticks. And then you turn the light off and you can see all these shapes. You can see this little girl right here in the middle. She's made a trapezoid, and it's got 3 triangles on the inside. So she's composed and decomposed to shape using these glow sticks. And this child has a rectangle, and you can see the 2 triangles composed to make that rectangle. And you could even demonstrate a slide here using the glow sticks. So I did include a link to Bedtime Math here. If you go back into the presentation, you can click that and it'll go, and it'll show you a video of math behind using these glow sticks. And it also has a handout for you to use with your students. But I did include the handout in your your handouts today. So if you go back into the files that I sent you, I also included some print games that are based on the investigation games that are online that I showed you today. Okay, so if you want to go and follow us, get on Facebook, get on Twitter, and share your experiences with us. I love to see really cool things that are going on in your classroom, and asking any of us any questions, or going back and seeing any of our presentations that we've done before. Okay, and KCM is here to support you. That's our mission. And like I said, if you are watching this, especially later on, and you want to join in on the conversation or have a question for me, please feel free to email me. And time to share. I'm going to hand it over to Kelly now.
So that's super cute. Look at your little summarizer. Is there anything that squares with your way of thinking? So that is a question that is asked to the group. Go ahead and unmute yourself. What about a point or 2 or 3 that you would like to make, and anything still circling around in your mind? A beautiful summarizer for our geometric focus.
I just want to say from my experience as a teacher, we bless a lot of things that aren't exactly true or always true. For example, when talking about geometry, it was just really resonating with me. I had a poster of the different geometric shapes on the wall, and I began to see the same thing like you were saying, Asher was saying, if the shape was, it was rotated a different way, for example, a triangle, if it looked like a pennant, you know, and upside down, the kids were like, that's not a triangle. It had to look exactly like the triangle that was on my poster that we talked about, you know, every morning. But anyway, I just wanted to say that being careful about, that made me more careful about talking about the specific attributes of the shape, and maybe not even naming the shape yet. So I began to kind of turn it around and just say, let's talk about what this looks like, what's special about it, without even naming, giving the shape a name. So thanks for bringing that back out.
Great, thank you.
Others for square, triangle, or circle?
I just had a question about drawing shapes in primary. I mean, fine motor is such a struggle at that age as far as forming letters and numbers and shapes. I mean, what kind of guidance do you have as far as being very delicate in that instruction?
You know, I just read an article about that, and they had an x-ray of a child's hand from like a 4, 5, 6-year-old, that set of children versus even when they get to 7, and how their hands elongate and change. So yeah, you're exactly right. They do struggle, and I know a lot of them struggle with their grip. You know, I don't know. Does anybody else have a thought about a great way to help kids with drawing other than tracing or using a ruler? And using those special grips, I know helps some kids.
I think at my school, sometimes depending on what the activity is, they're asked to free draw and you don't really critique those as much. But then like this activity like using a template, a plastic template where they can draw, they have, or it's a stencil, I guess is the better term for it, of all the shapes. And then they can use those to move them around, yes, or even using the manipulatives like you showed, we all have those to draw from, to get their, again, that muscle memory of, oh, this is how it should, how it feels to draw it. I don't know, that's kind of what we do at our school.
Great, thank you. Or graph paper or grid paper, that would give them something to go by too.
So
One thing that we did,
one thing that I know that's important, and that is please give them the gift of time. Please give them the gift of time. So this idea of muscle memory, this idea of time, and many different ways to be able to do that. So that's the thing that we say here at the Kentucky Center for Mathematics. The best thing that happened is that we did not have to do the end of year assessments. And so now is the time to really think about how children can smolder on their skills that they have. But Bonnie, great presentation today. Really loved all of the virtual examples that you gave. And so we are so glad that you guys joined us in the afternoon. And thank you for being here. Tomorrow, we're going along the progression route. We will be at 3-5, thinking about those geometric concepts that are important at 3-5 with our very own Lisa Riggs. So we see you tomorrow. Bye, guys.
Thanks, everybody.
Thanks, Bonnie.
Thank you.